Hi everybody, welcome to the self-check section 7.1 video. Let's go ahead and take a look at number one. So the length of time taken on the SAT for a group of students is normally distributed with a mean of 2.5 hours. So mean equals 2.5 and a standard deviation of 0.25 hours. So standard deviation equals 0.25. And a sample size of n equals 60 is drawn randomly from the population. So A, B, and C are asking us to fill in some blanks about this question. So let's go ahead and answer what it's asking. So in words, capital X equals. So this capital X, this is related to what we were doing in section 6.2 with just a regular normal distribution. So what capital X is in the context of this question is the time in hours it takes one student to take the SAT. Okay, so when we're talking about X, it's just talking about one student. So now when we do X bar, here's where the sample means come in. What X bar is telling us is the time, also in hours, it takes not one student, but the sample of 60 students to take the SAT. Excuse me, I have a typo here. It's not time, it's the mean because we're talking about sample mean. So the mean in hours it takes that sample of 60 students to take the SAT. Remember, for the central limit theorem, we were talking about sample means. So part C is asking us to fill out the blanks with the distribution of the sample mean. And what we would have here is just the normal distribution. Our mean is still 2.5. Let me write out the general form of it. So mean. And remember with our sample means, our central limit theorem, our standard deviation changes. So it's going to be standard deviation over the square root of our sample size. Okay, so in the context of this problem, let's go ahead and fill in these blanks. So what this provides for us is sample mean of a normal distribution. Our mean is going to stay the same, 2.5. Our standard deviation is 0.25, and it's over the square root of our sample size, which is 60. Okay, so that's the annotation for our distribution. Okay, so let's go ahead and find some probabilities and some data values. So question D is asking, find the probability that the sample mean is between 2 hours and 3 hours. Okay, so much like we were doing before, we want to draw a distribution. Our mean is 2.5, and I want to find the probability between 2 hours and 3 hours. So I want to find the probability of the shaded region right here. So when we want to find a probability of a distribution, we are going to use normal CDF. So 2 is less than X bar, not just regular X, it's X bar, since we're dealing with a sample mean, which is less than 3. We're trying to find between those values, and it would be normal CDF, and our lower limit is 2, our upper limit is 3, our mean is 2.5, And our new standard deviation for the sample mean is going to be 0.25 over the square root of 60. Okay, so let's jump to our calculator and input our context in. So we're going to the same second vars. We have a normal CDF, and our lower limit was 2. Our upper limit was 3. Our mean was 2.5. And here's where we enter in our new standard deviation. Be careful when you put your standard deviation in. Make sure to put divide, don't put multiply. Divide by square root. So second x squared. And you're going to have 60. And then the way to get out of that square root, you want to press the right arrow. So you want to press arrow and then just close it up with a parentheses. Okay, so let's go ahead and hit enter and get our value. So we get a value of 1. So that means basically the sample mean is all between the values of 2 and 3. So what we end up here with is 1. So that's saying this whole distribution, the probability of that is 1. The whole distribution. Pretty interesting. Okay, so let's go ahead and do part E. And same thing, we want to find the 80th percentile for a sample mean of 2 hours. Excuse me, for a sample mean round to 2 decimal places. So let's go ahead and draw this distribution. I want to find the 80th percentile. So I know 80th percentile would be somewhere all the way up to the right because it's almost 80% of your data. So let me annotate this is 80%. And so what we need to do here is use inverse norm. So K equals inverse norm. My area is 0.80. That's what I'm looking at. My mean is still 2.5. And then my standard deviation is still at 0.25 over square root of 60. So let's go ahead and jump to the calculator and find our K value, meaning our 80th percentile. So second distribution, inverse norm, 0.80, 2.5, and we're going to have 0.25, 0.25 divided by the square root of 60. And just remember to use that right arrow to get out of the square root. Okay, so parentheses. So we have our setup right here and just hit enter and we get our 80th percentile, our cutoff value, which is 2.53. So let's go ahead and write that down. So we have 2.53. And so this is that K value on our distribution. So basically, 2.53 is the 80th percentile. Okay, so that's it for number 1. Thank you for watching, and I'll see you in the next video.